So, Gerrit, without further ado, I think stage is yours.
Yeah, I would say so from 3D printing, we are now way far apart. I will leave this to some shady startups in Saxony. Nevertheless, we focus on the enabling of scaling lithium metal electrodes in the manufacturing process. And if you look into batteries, I guess we learned today a lot about ignition of cells and everything, but what's inside is more or less on the anode side, mainly graphite. So somebody's talking about some silicon anodes, but if you look into the status quo and into the world of batteries, most of the time it's graphite. And so therefore there is no leaps in energy density possible anymore. And we nearly read to go to the next steps. And when we do this, and when we look into the emerging solid state startups, mainly in the US or in the rest of the world, they're all focusing on one component, which is lithium metal actually. So in theory, lithium metal has 10 more times capacity than graphite. And also, when we look at the supply chain resilience, lithium is way more distributed around the world than it's graphite, and it's way easier to get out of China or to get it, maybe from Portugal or something like this. And as mentioned, so solid state batteries mainly focusing on lithium metal or solid, or the solid electrolyte is mainly the enabler for lithium. Depends on how you want to frame it. What we actually do is, we manufacturing the lithium, but also we cannot use it only for solid states. We can also use it in a different way due to our process. The current process right now to produce lithium metal electrodes is, on the one hand, extrusion and lamination process, and on the other hand, it's a physical vapor deposition process. So we have, on the one hand, the very good commercial ready electrodes, but you have a thickness of 50 to 100 microns, and this is way much or way more than you actually need. And on the other hand, you have the lithium metal, which is deposited by vapor. And you can imagine that the vapor deposition is very, very slow. So it's also, limited in scalability. And scalability is most of the time a buzzword that everybody just, throw into the room. And so nobody asks about it. But what does this actually mean? So it's not scalable. So when we look into 35 gigawatt hours of European production plant, or what was more or less the standard production for Europe for 2030 in the past, with an average physical vapor deposition equipment, you need 744 machines above for producing the lithium metal electrodes for this, which is around 1.3 billion of capex. So therefore, I would say we can put a tick behind it that PVD processes are not that scalable. So for this, we developed a liquid application of lithium. So we use molten lithium, and we coat this on a substrate and use a temperature-induced in situ reaction to build out such a 3D network inside, which also helps us not even to use alloys or have this 3D skeleton inside, but this 3D skeleton actually increases the bonding of the material, so we don't have problems with lamination. It also prevents actively the dendrite growth. So therefore, we have a way more even distribution of the current, and therefore we are able to produce higher cells or bigger cells, and also we are able to use this material to build next-gen batteries with liquid electrolytes, not mainly solid-state electrolytes. So for this, we can be the enabler for leapfrog when we can actually make this process scalable, and this is what we are working on right now. So there was quite a rush. Nevertheless, we are based in Aachen. If you have some questions, feel free to ask.
All right, Gerrit, thank you very much for the elaborating talk. Are there any questions up front? If not, I have a technical one. On the last slide, you had the current collector of 12 micron. Could you go thinner with this?
Yeah.
Because the current state of the art is way thinner, right?
Yeah, so the current collector, of course, is more or less 6 microns when you look into the industry. Because yeah, we use the temperature-induced reaction between the copper and yeah, the lithium. For example, currently we prefer a thicker one that we don't bring a hole inside.
Yeah, sure.
But with the lithium, we can go, or our last electrodes that we produced had a thickness of 3 microns. So therefore, also just give us thinner foil, and we can use this as well. It's not a big issue.
Okay, understand. And from the entrepreneurial point of view, in your technological development, but also from the business case and scaling your technology, where are you? To just understand what are your next steps and
Yeah, so currently we are more or less in the funding stage so that we now can ship samples to customers.
Mhm,
So we have a production plant ready and we are now scaling to a width of 50 millimeters.
mhm,
So yeah, right now we are able to then produce single sheet pouches with 50 millimeter width of the electrodes and but right now, we're quite confident with 25 millimeters. So we mainly focusing now on coin cell development and improvement on this side. But yeah, in the next days, more we mentioned end of this quarter, we will be or customer ready. And then
mhm.
we will start shipping lithium chips on copper, and also customer solutions to our pilot customers.
Okay, good. So very promising and yeah, great success. Really inspiring story.
Thank you.
So